video for section 3.1 is going to be all about the different types of probability. Coincidentally, this is the third video in 3.1, and there are three types of probability. So let's jump into those three types, see some examples of them, and yeah, let's go. So the first type that we have is called classical probability. Classical, or you also may hear it called theoretical probability. That's our first of our three types. Classical probability, or again, it could also be called theoretical. This is used when each outcome in a sample space is equally likely to occur. Okay, so we do have a formula for that. If you're one that you're just more formula driven, it is the probability that event E occurs is equal to the number of outcomes in event E in event E over the total number of outcomes. Okay, so let's see an example of classical probability. So this is going to be, let's see, example 5. Okay, they tell us that we roll a fair six-sided die. Find the probability of each of the following events. A would be rolling a 3. B, rolling a 7. C, rolling a number less than 5. And D, rolling a number greater than 0. Okay, so let's think of, before we really get too far into these events, let's first get our sample space. Well, if it's a fair die, what all can I roll? It's a fair six-sided die, like one you'd play Yahtzee with. I could roll a 1, 2, 3, 4, 5, or 6. Okay, so the probability of rolling a 3. Well, there's only one thing that satisfies that. So our probability here would just be 1 out of 6. There's only one 3. 1 out of 6. Probability of rolling a 7. You're like, what? A 7? Did you mistype that? Nope. I'm asking you, what's the chance I roll a 7 if I have a fair 6-sided die? Well, there's no 7s, so 0 out of 6, which is just 0. Okay? Rolling a number less than 5. Well, what's less than 5? 1, 2, 3, and 4. So that probability then would have to be 4 out of 6, which reduces to 2 out of 3. And then rolling a number greater than 0. So what are our numbers greater than 0? 1, 2, 3, 4, 5, and 6. Look, I just listed all of them. What the heck? So this would be 6 out of 6, which is just 1. Okay, so notice some things here. For one, what are all of our probabilities between? All of our probabilities are between 0 and 1. That's not a coincidence. So let's come down here. I'm going to put a few takeaways. All probabilities are between 0 and 1 inclusive. So if you wanted to list that as like a, just put it in like math symbols, for instance, we could say that probabilities have to be between 0 and 1. So 0 is less than or equal to the probability of E, which is less than or equal to 1. That's always going to be the case. I mean, I know we like to talk and say, oh, well, how sure are you about something? I'm 110% sure. What? How can you be 110% sure? Or another, they say, well, how much effort did you give? I gave 110%. If you gave 110% effort, that means you gave all the effort you had and then some. Where did that some come from? Did you cut off your arm and give it to them as well? It's like a peace offering? I mean, that's creepy. But no, all probabilities have to be between 0 and 1 inclusive. Period. End of story. Another takeaway. We know a simple event is one with just one outcome, but we have more. We have two different types now of events. Now that we know some about probability. A certain events have a probability of 1 or 100%. Impossible events have a probability of 0 or 0%. So, of these, which one would be a certain event? Well, this one with a probability of a 1. We call that certain. That's a certain event. And you probably thought that when we were doing it. Rolling a number greater than 0? They're all greater than 0. Everyone's a winner here. It's certain. It will happen. No ifs, ands, or buts. It has to happen. When I did the one rolling a 7, you may have even said it to yourself. That's impossible. Well, that's the name of it. This is called an impossible event. Okay. So that's classical or theoretical probability. I mean, it's just, again, it's all theory based. The second type probability is called empirical, or you often may hear it called statistical probability. This is based on observations obtained from probability experiments. Now, we typically use this when outcomes are not equally likely. Okay, so just like with before, we have a formula for it as well. A probability of event E occurring would be the frequency of event E divided by the total frequency. Wait a minute, this sounds like something we've done before. Or S over N. Wait a minute. I think this is called relative frequency from chapter 2. Relative frequency. My handwriting is atrocious today. Yikes. From chapter 2. So that's empirical or statistical probability. So we take the frequency the event happened over the total frequency. Okay, let's see an example of this one now. So example number 6. It's also going to be a word problem. Okay, a company is conducting an online survey of randomly selected U.S. adults to determine how they read books during the past year, if at all. So far, 1,490 adults have been surveyed. The pie chart shows the results. Note that digital books include ebooks as well as audiobooks. What's the probability that the next adult surveyed read only print books during the last year? Okay. So only print books. How many did that? Read only print books, 578 did it. How many total do we have? Well, 1490 is our total. So then the probability of only print would equal 578 over 1490, which is roughly, to 3 decimal places, 0.388. And there we go. That is empirical probability. I mean, that's just empirical probability. I don't know. Anyways, let's see here. This leads us, though, to something called the law of large numbers. Law of large numbers. This is, as an experiment is repeated over and over, the empirical probability of an event approaches the theoretical or actual probability of the event. Okay, so let's say we're flipping a coin. Well, what is our theoretical probability of getting a heads? Well, it's only 1/2. But that's not, if I flip a coin twice, I could get heads both times. So the probability of a heads of those would be 1, not 1/2. What this is saying, I'm going to pull up a demonstration just so y'all can visualize it. Hopefully I remember where it's at. Applet. Okay. Where did it go? Law of large numbers. There we go. Okay, so I'm going to change this percent to 50%. I mean, it says they're shooting a basket, but let's pretend they're flipping a coin. So, oh, they missed. So now their probability is 0%. They shoot again. They miss again. 0%. Miss again. 0%. So far, they've attempted 3 shots and made 0. You're like, wait, we were talking about coins. Now we're shooting basketballs. I still have 50% as the theoretical probability. So I want them, instead of us sitting there and just doing it over and over, I'm going to have them do 50 shots. Okay, so as you can see, so on the 4th shot, she made 1 of them. Well, now that's 25%. Second shot, she made it again. Now she's up to 40% because she made 2 of the 5. But as we go on, do y'all see how these dots are getting closer and closer and closer to the theoretical 50%? I'm going to have them do 50 more. 50 more. 50 more. So it varied widely at first, but now we're kind of settling in theoretically on the average. If we look down here at the shot statistics, she's at 51.7%, having shot 203 shots. I'm going to do 50 more. Now it's at 49.8. So we're getting pretty stinking close to 50%. Okay. So I'm going to actually screenshot the chart here. Empirical Why does it not like how I spelled it? Because that E should be an I. Insert screen clip. So we can see that at first it was shaky, but now we're getting close to the 50%. Okay. That's the law of large numbers. So at first, thing to remember here is at first we were not anywhere close to the theoretical amount, but then as we went over and over and over, we got closer and closer overall to 50%. That's the key to remember with this law. Okay, now, the third one. The third type is called subjective probability. And I know I'm over my 20 minutes. But try to get all three in one video. Subjective probability. This is results. This is what results from intuition, educated guesses, and estimates. So I don't have like a set example here. Actually, I do. I do have a set example for this one. They want us to classify, but, well, let me back up. So subjective probability, like it says, it's intuition, educated guesses, estimates. It's like what you feel with your gut. What is your gut telling you? What do you feel in your gut? That's subjective probability. This is a lot of what's used in the stock market, I'll be honest. So, stock market, total subjective probability. Okay, time for example 7, so we can end this video. Classify the following as one of the three types of probability. A, the probability that you will get an A on your next test is 0.9. Well, what do we think here? What kind would this be? Do we have theoretical data here? No. Do we have subjective data? Have you taken this test that you're going to take over and over and over and over and over? No. That leaves us with subjective. It's just your gut. You know the material, you think you're going to do well, so you're like, I'm 90% sure I'm making an A on this. So this is subjective probability. Because it's most likely based on an educated guess. Okay, the next one. The probability that a voter chosen at random will be younger than 35 years old is 0.3. Well, if we think about this one, they have a database of voters, of registered voters. So we could pull data from it. And if we pull data from it, that becomes empirical. So we have data already. We've collected the data on the registered voters. So this is most likely based on a survey of registered voters. Okay, and the third one. The probability of winning a 1,000 ticket raffle if you bought one ticket is 1 out of 1,000. Well, you bought one ticket, they sold 1,000. We're going to assume each ticket has the same chance of being drawn. So that would make this classical probability. You know the number of outcomes, and each is equally likely. Okay, so those are our three types of probability. We have classical, empirical, and subjective. Stay tuned for our last video over section 3.1, where we look at complementary events and then just kind of tie everything together.